JT5 or something. So we gave that the green easy button, audio. Radio control is how you read the radio's frequency, set it to different modes, how you activate PTT, how you do CW. Almost every radio today has either a serial port, a CAT port, a CIV port, which is what I call it, or it has a USB to control the radio button. Number three, control. How do you control everything else in your ham radio station, like the AC power outlets, the antenna switching, move the rotator, turn the tuner on and off or adjust it, turn the amplifier on and off and adjust it. Basically everything in your shack needs to be either computer controlled or fully automatic to make remote operation easy. This is really the hard button. Getting everything else in your station to work is probably 90% of the effort. Getting your radio to work is the easy part. Getting the audio is the easy part. And you do need fairly good internet service. Not excellent internet service, but good internet service. You really need a low delay, a low latency, a low jitter issue. If you can keep the latency under 100 milliseconds, you'll be able to operate remote fairly well. Some people go up as high as maybe 200 milliseconds. Some really good connections are down in like the 20 milliseconds, and it's just like being at the shack. You can't even tell the difference. The speed you need, basically, if you have it over about 1 million bits per second, you're going to be fine. You can actually operate with much less, maybe like 400 kilobits per second, but then you start having to cut things back and use lower quality audio. And so as long as you're up over 1 million bits, you're going to be fine. And on the radio end of your connection, you really want to have a public visible IP address, because that makes connecting to your system so much easier. If you actually have to keep track of a changing IP address through a dynamic name service, it just gets much more complicated. So if you can, at the radio end at least, try to get a fixed IP address. And the other need we didn't want to talk about is patience and willingness to solve problems, because there's a lot of that. There's a lot of that at the start, but once you have things working, remote systems are very reliable. It's just that first hump of getting things working that's sometimes it has you tear your hair out. There's 4 ways that people are using these days that are proven ways to do remote access. It's not blue sky, it's not imaginary. You could actually do all these right now. Number 1 is use a web browser. RemoteHamRadio.com is the big player in that space. They have 10 good stations. You can access them with a Chrome web browser, a smartphone, a tablet, Android or iOS. You can use a hardware interface box. You can use a K3 mini front panel. There's a good review of it in May 2013, although that's getting a little dated now. They have a free 30-minute trial. How can you go wrong with that? They basically cost $99 a year, and then the stations cost 9 to 49 cents per minute, depending on which station you use. Although they have a Hamvention sign up, so you can sign up right now for only $49 a year. There's a link, or just go to their website. They have lots of information there. This web browser access is really great for DXing. You'll never miss a rare one again, because you can get on the air. It's too expensive to sit around and rag chew this way. They have some nice stations in Puerto Rico or Haiti, so you can have fun being a DX station yourself. It's a good backup system. If your station's down or you're visiting, you're far away from your station, you can always use this. And they do have some other premium stations available at a higher cost if you find you really like it. The second way, software programs. This usually requires you have a shack PC that's on and operating, and you have to have software both in the shack and on your end as the operator. RemoteHams.com is widely used. It's free to sign up. Some of their stations, if you want to use their stations, kind of charge you a club membership fee. But this is a good way for your club to put your club station on the air, for instance. You have to use their software called RCF or client. You can also use their software to set up your station as a server. So they provide both halves of the software. There's a good article about it in a very recent QST, April. Another popular software program is from ICOM. It's the RS-BA1. They do charge $99, although with what you spend for a radio, I think they'd throw it in. But it works pretty well if you have an ICOM radio. You can see from the picture how easy it is to set up. You plug the USB cable in to your Shack PC. The ICOM software takes care of lots of the functionality, goes over the internet to another PC running the ICOM software. It works well as long as you have an ICOM radio. There's a bunch of other software programs like Ham Radio Deluxe has a remote server built into it. Kenwood has something called the Radio Control Program. There's other software from individuals like TRX Manager and DF3CB make some very nice software, and N4PY makes some nice software. So if you're thinking of going down the software route, you might look at a few of these. RemoteHams.com is free. It's hard for me not to recommend that. These other software programs usually cost a little bit, but they're certainly worth it for all the capability they provide. The software is going to solve a lot of the problems that you don't want to have to solve on your own. And you do get some vendor and some user group support. So using software programs is a pretty good way if you want to kind of have a community where you can get some questions and answers from people and get things working. But remember, this mostly solves connecting to the radio. The rest of your shack still needs to be computer controlled or automatic. The third way is what's called a remote desktop, which in the IT world they call a VNC program. Again, you need a Shack PC, you need software on both ends. You set up your Shack PC to control everything in your shack. You can actually use any software you want, even if they don't know anything about remote. So you could use N1MM Plus Logger, you could use a DX Lab software, anything you want, which is why a lot of people like this remote desktop method, because they can use whatever software they really want to use for DXing or whatever function. Then you use remote desktop software on the Shack PC and on your laptop, and you connect in and you can see your Shack desktop. You can see your Shack PC and do everything from your laptop just like you're at your desktop in the Shack. This method probably needs better internet access than some of the others because it's kind of duplicating that whole desktop view across the internet for you. So sometimes that can have some lags and need a little more speed. But this is a very common function for remote workers in the IT world, remote workers in a lot of businesses. So this is pretty well proven out, and you can do a lot this way as long as your shack is fully set up to work, to control everything in your shack. There's lots of remote desktop programs. The best ones to use will include the two-way audio for you, so you don't need an extra add-on for the audio. Ones that include two-way audio are TeamViewer, Chrome Remote Desktop, Splashtop, Microsoft Remote Desktop. If you have a different remote desktop program, because maybe you use it for work or something else, you can actually add on audio pretty easily with Skype or a program called Remote Audio. You can also use the same kind of software that online game players use to chat back and forth with audio, and they're like Mumble and TeamSpeak, and there's lots of extra audio add-ons, but if I was going to start this way, I'd use a program that already has audio built in. The fourth way that really works is what we're going to call remote front panels, because hams like to have buttons and knobs available. They don't like always clicking on the screen and things. So there's really two ways to do this. One is with the remoterig.com boxes. So you can take any radios that have a detachable front panel, or you can use a second radio in what they call twin mode, and you extend that panel across the internet to control your radio. The remote rig boxes do a lot of things. They handle the keying, the audio, the rig control, extra serial port. They do a lot, CW, they can key FSK RIDI, they have a WinKeyer built in. So these boxes can do a lot, but that also means they're kind of complicated to set up to get working, but they can do a lot. The second way for remote front panels is Flex Radio provides a front panel called a Maestro, which can be wired or wireless and talk to your Flex Radio. Up until now, you could only do that over a local network or you could do it over the internet if you set up your own VPN. But Flex Radio just announced that in Smart SDR 2.0, they'll have something called Smart Link, which will take care of that for you. So now, later this summer, when Smart SDR 2.0 is out, the Flex software will take care of all those connection issues for connecting your Maestro front panel to your Flex Radio over the internet. You might want to go by their booth and see the Maestro if you've never seen one. They're very, very slick, very neat. Flex Radio also has 2 new radios that are introduced today, and you can buy them with or without a front panel. And when you buy them with the front panel, basically you're getting a Maestro stuck on the front of the box. So kind of neat. What's great about these is you get buttons and knobs. This can kind of be an expensive way to go because they're selling you extra hardware. You have some extra boxes in between maybe. Like I said, it can be difficult to get this set up the first time, but then it's very reliable. Once it's set up, it just works and works and works. You walk up and push the on button and the radio comes on and you're on the air. So if you really like having buttons and knobs, this is kind of a route to go. Remember, mostly this takes care of the radio. The rest of your shack needs to be computer controlled or automatic. I'm sorry to say that every time. There we are, station control. The rest of your station needs to be computer controlled or automatic. There's lots of crazy solutions. Here's just a few that I know work well for people. To switch AC power outlets on and off over the internet, Digital Loggers Inc. makes a device called a web power switch. 8 switched outlets, automatic reboot if the internet's lost, access it through a web browser. It's fantastic. They're $170 though for 8 outlets, but boy do they work well. If you're kind of a cheap ham, you can go with the Belkin Wemo switches. They're only 30 bucks, but you really only have 1 outlet. Antenna switching, if you need more antennas than your rig can select, because a lot of radios have a button, antenna 1, antenna 2. Well, once you need 3, 4, or 5 antennas, you have to go to a band decoder and a remote antenna switch switched by your band decoder. So then you can basically set up any antenna you want on any band. You could have multiple antennas on a band and switch between them. So a lot of contest stations are very familiar with this because they set up their multiple antennas to be automatically switched when a radio goes to a band. So it's a little more complicated, but it gives you lots of flexibility about which antenna is on which radio, on which band. Usually you should include a dummy load for some testing if you can. Rotators are one of the worst things to deal with. Some software that works really well is from Green Heron Everywhere. There's also a software program called PST Rotor AZ, which controls rotators very well. That little picture there is of PST Rotator AZ with a rotator and a step IR control software all built in. A lot of logging software can also control basic functions of your rotator, like just send them to one heading, but they can't do a lot of extra configuration. If you have antenna tuners or amplifiers, well, if you have a manual antenna tuner, you know, with knobs that have to be turned, or a amplifier with knobs that have to be tuned up, you can actually use them on one band. So if you leave them so that they're switched in line on that band, they'll work fine. If you want to use them across multiple bands, you're probably going to have to look at a automatic antenna tuner and an auto-tune amplifier. And all the new solid-state amplifiers work very well, auto-tune, band switching. So there's a lot of new amplifiers available that will let you work across multiple bands. I think this is my last slide, all right. Some of the news of the year, RemoteHamRadio.com put a new premium station in Eastport, Maine, and they've already used that station. Various people have used that to win major DX contests like ARL sideband, CQWPX. The RemoteHams.com software is in the QST magazine in April. Very good article. I recommend you look at that if you can. Digital Loggers Inc., that web power switch, which switches AC. AC outlets, you can now get it either wired or with Wi-Fi. So if you really want to set up your shack to be wireless, they now have a AC power switch which you can access wirelessly. We talked about Flex Radio. Smart SDR will now work across the internet. The 403A company has provided what they call Genius products, which are really set up well for remote control of antennas and rotators and band switches and filters. So the 403A products are really interesting if you're setting up a remote station. There's some new remote-ready 1,500 watt solid-state amplifiers from Elecraft, Expert, and Flex Radio. So you're no longer kind of limited to low power. You can actually have your remote station be full high power and easy to operate. Some interesting designs that you might want to look at if you're thinking about designing your remote station in advance instead of incrementally working on it are at W5FCX and at the AB1OC, AB1QB blogs. They both provide a lot of detail about how they designed a remote system, how they implemented it, what parts they used, and they help you understand how to go through the process. So that's all I had to say as an introduction. Now we're going to hear from our expert, Stu, K6TU. Yeah, so those designs are by W5FCX at W5FCX.net. And the AB1OC blog, you should probably just Google AB1OC and you'll find his blog. And you can see my slides at K6UFO.com or through my QRZ.com page, so you don't have to write it down now. We're really lucky today to have Stu come and talk with us. Stu, K6TU, was first licensed in 1973 as G8HQA. Thank you, we have a DX visitor today. He moved to California. He designed and implemented a whole remote station in his Woodside, California house. Woodside's kind of a very stuffy homeowner association controlled area, I guess I'd say. So Stu overcame those kinds of obstacles. Stu's developed a lot of ham radio related products. He runs the K6TU.net propagation service. So if you're ever interested in propagation or when to work a de-expedition, the K6TU.net propagation forecasts are very useful. He's also produced some products to work with the Flex Radio, like the little Flex Radio control knob. And he also has several iPad applications for controlling his ham radio station. So Stu, come on up and thank you for speaking to us.
Thank you, Mark. Let me just switch this here real quick. So despite Woodside being a stuffy community full of people who the epitome of not in my backyard, this is actually a picture of my tower. I have a completely legally permitted tower in Woodside, California. It's only one of 3, but there are some others, so it's quite possible. You just have to figure out how to work with the local council and the authorities, and sometimes you can get what you want. Not always. So I've operated remote now for about 14 years, a combination of remote at home. So all of my equipment and antennas are about 500 feet away from where I operate in the house. The antennas are probably about 200 feet then away from where all of the radio equipment is located. And together with Kevin, K6TD, we have a remote contesting station on a mountaintop near San Jose called Mount Umunum. It's about 3,500 feet above sea level. It's the site of what used to be part of the Defense Early Warning Line. And Kevin and I are both avid contesters, so for us, if we're going to operate remotely, we want to be at the radio. So we're very much focused on quality access to the radio as though we were sitting with it right in front. So what I'm going to talk to you today, I'm going to give you a very brief introduction about software-defined radio. The remote that I use both at home and the remote that we have on the mountaintop uses Flex Radio, 6000 series products. Everything is computer controlled. I'm going to talk about why use an SDR, particularly in the context of remote. And then I'm going to give you some observations, performance considerations, and so on about what it takes in order to get successful remote operation. No, this is not online. I'll figure out some way of producing some extract of this. So there are broadly defined two different architectures for software-defined radios. I'm not going to go into these in depth. I just wanted to highlight the difference of them. The top one is exemplified by the older Flex Radio 5000, 3000 series, which were really direct conversion receivers using DSP on a PC or a computer connected via some kind of high-speed interface in order to do all the digital signal processing. The more modern radios, of which Flex Radio is an example, as are the Apache Labs Anan products, they use what's called direct sampling, which is where you have an analog to digital converter attached directly to an RF amplifier and the antenna. And that amplifier is the only analog component in the radio. Everything else is done digitally with very high-speed sampling, and everything else is done in software. So why use a software-defined radio? So with the digital sampling, it's possible to get performance by eliminating pretty much everything except that one analog component, the low noise amplifier that's connecting you to the antenna. Because you have eliminated all of the analog components, you can create much more perfect function blocks in the radio. So I'm sure those of you familiar with mixers, you know that mixers produce intermodulation products. They produce spurious responses, image responses. When you do a mixer in software, you can make much better performance. You can achieve performance levels that you frankly can't reach in an analog world at all, not at any price. So one of the advantages of having the radio now all in software is that you can tailor the radio's operation for the specific mode that you want to operate, whether it's digital mode, sideband, CW. So you really can focus the operation of the radio around not only the mode that you operate, but the type of operating you want to do, whether you're working DX, whether you're working contesting, rag chewing, whatever. Because the radio is now in software, you get enhancements through software releases. This is both good news and bad news. The good news is you get the enhancements. The bad news is you're somewhat at the mercy of the vendor of when they come out with those new software releases. And developing software is both time-consuming and it's expensive. So, you know, as hams, a lot of hams expect to get ongoing stuff for free. And at some point, you know, free as in beer, or free as in milk has its limitations. Also, making the radio in software means that it's primarily computer controlled. It means that you can get a level of simplification and ease of automation that you can't get anywhere near as easily with a conventional radio. And particularly now in the case of the Flex 6000 series radios, the radio is really a network server. So the radio sits on the network. You can connect to it either via the local area network or now with, with Flex Radio's latest release, you can connect to the radio across the internet without requiring additional hardware support. So one example here is that you get a visual radio. This is a screenshot of a Maestro that's running remote, actually in a RTTY contest. Using a visual radio brings your vision into use as a sense for operating the radio. And one of the things that's very noticeable about a waterfall like this one at the bottom is that you really have a history of what's going on the band. In this particular case is about 20 seconds worth of history on 20 meters. So if you're looking, you can see if I decided to tune up the band, there's another station right here. So it eases operation for things like search and pounce and really brings a whole new dynamic finding weak frequencies to call CQ in a contest and so on. So let's talk about remote operation with the 6000. I've got one slide here which I'm not going to cover I'm going to try and hit on the points and leave you to read as I speak. The network really, when you're dealing with remote, the network is the critical part of your station. It's more critical than the coax connecting your radio to the antenna, because without that network, you have no station. Latency and packet loss are key. You have to really be aware, if you want to have an at-the-radio experience, you have to be thinking about what the network connectivity is between you and the station. I've operated my station at home when I was on business travel to India. It worked, sort of, but the delays were very hard to deal with. There's no way I would have been able to have adequately contested with that. On the other hand, I could use the radio. So you have to understand the limitations that the network connection will either enable you or will get in the way. And at the end of the day, distance and speed of light are physics. You can't overcome them. So, you know, one trip across the United States is about 40 milliseconds in one direction. That's just, you know, you can't get rid of it. That is what it is. I want to give you a little bit of thoughts about network issues because people often just think, well, the network's there and that's fine. And that's not always the case. Particularly if you live in an urban environment, Wi-Fi is going to be potentially a challenge for you. If you're on the 2.4 gigahertz Wi-Fi band, you are going to pick up all of your neighbors, and those neighbors are going to limit what bandwidth you can get. I frequently travel to New York on business. From my hotel room in Manhattan, I can see over 100 different Wi-Fi access points. So, you know, in a high-density urban environment, Wi-Fi can be a real mess. So you really want to try and use the 5 gigahertz band where you can. You want to also make sure that you pay money for a quality access point. To reinforce the point that's written up there, cheap Wi-Fi access points are cheap because they're nasty. And so the cheap and nasty ones do not work very well. So spend the money in order to get one that's got really good reviews, particularly if you're going to do remote operating. Look for one that is recommended by gamers, because the gamers, particularly when they're doing these first-person shooter games, they're really very attentive to what the delays and performance are. Really, I'm a very strong proponent of minimizing traffic across the network, particularly across the internet. We practice what's called a remote compute heavy model, which is we have one or more computers at the remote site, and we run whatever is compute or traffic critical. For example, the digital software, if we're running on a RIDI contest, the RIDI software runs on a PC that is physically by the radio, and then we control that software remotely using a combination of a Maestro and a VNC, as Mark mentioned in his presentation. So the radio as a server gives you a huge bunch of advantages because the radio is being designed to work across a network. So it means that all of the functions the radio provides are accessible across the network, and you don't have limitations between, okay, well, this will work when I'm physically sitting at the radio, but I can't get at this particular function because the vendor didn't extend it through whatever computer interface they provided to the radio. So you need to be now thinking about the user interface. The user interface, even though it may be a remote front panel, as Mark mentioned, with a Maestro or as a K30 as an example, but you're really using what is a computer itself. In the case of the Maestro, there is actually a tablet computer embedded in that unit, together with a set of knobs that allow you to control the radio across the network. You can get multiple PAN adapters. PAN adapters are a great benefit. They're also bandwidth hungry. To run a good resolution PAN adapter, you're looking at around 3/4 of a megabit, so 750 kilobits a second all the time. And one of the things to be mindful is that most internet links, whether they're business or home links, you have far less bandwidth up into the internet than you have down from your service provider. I do most of my business from my home. I have 150 megabits down. That's great. I only have 22 up. 22 is pretty good. I'm not complaining, but that gives you an idea of even when you're paying on a business class connection, what level of asymmetry you have. You have to start thinking about how you get computer and audio control to the radio. That's also done across the network. And a lot of, by also having the radio provide data across the network, you can also get access to what's called the INQ data. So this is essentially the samples of the IF, which allows you to run CW skimmer or a RIDI skimmer and look at 100 kilohertz of the band at one time. You can imagine the amount of bandwidth that that requires. So an INQ feed, if you're going to run it across the internet, is of the order of 2 megabits a second for a reasonable sample rate. So you begin to see why we practice this remote compute heavy model. We want to minimize the traffic we pull over the network and keep all of the high speed and short latency stuff physically in the station. And as the point goes at the bottom, you can operate whether you're running single up one radio or SO2R, you can do that remotely as well. Mark mentioned Ham's fascination with knobs. It's not just a fascination, it's a requirement. For those of you who've tried contesting with a computer system, if you don't have a knob, you'll find that the workflow is a disaster. It's very slow. If you're forever having to reach for the mouse in order to change something on the radio and then go back to the logging program, it very quickly becomes unappealing. So it was actually the original reaction to this when I started contesting with a remote Flex 5000 that led Kevin and myself to develop what became the Flex Control, which is a very simple knob and a minimal number of buttons on it in order to be able to tune the radio remotely. Maestro obviously gives you both the display, the touch capabilities, and a lot more knobs in order to control the radio. In practice, you can get away with one knob. It's somewhat of a minimalist approach. When there was only one knob and that was all that was available, it was a great solution, but Maestro is much better. In the case of remote audio, this is one area where I think a lot of the vendors still have significant work to do in their products. Most of the commercial ham radio support for remote audio, including that in Flex Radio, today introduce an amount of delay that is borderline. And not only does it have issues in terms of delay, but depending upon whether if you're operating CW or if you're using a voice keyer, for example, with a contest logger, there is limits on what kind of audio feedback you get in terms of side tone or monitor. So in the case of the Flex Radio, if you're operating with remote audio, you can't monitor the audio into the radio, and you can't get a side tone if you key the radio remotely. So we've actually implemented our own solution of this. There is a couple of good solutions, although not inexpensive. You can use a pair of remote rigs and just use the remote rigs for the audio control, or you can use there is a Tobias DH1TW implemented a software package that runs on a couple of Raspberry Pis called Remote Audio that was specifically designed and optimized to get low latency across the internet. So with CAT and audio integration, and again I'm going to let you read this while I speak to it, the CAT and audio are provided as services by a server that runs on a computer. You can either run this on the remote computer, which is our preference, or you can actually do it over the network. I certainly do with my system at home. Admittedly, I have gigabit Ethernet that is connecting me to the radio, even though it's some distance away from where I operate. One of the advantages is that the CAT server is presented to you as a series of virtual COM ports. Similarly, the Digital Audio Exchange, DAX, presents you a series of virtual sound cards. So it eliminates all of the wires. So you don't need RS-232 cables, you don't need audio cables. No audio cables and no sound cards means no hum and no ground loops and no RF getting back into the radio when you're running digital modes. So there's a lot of advantages that you gain when you start going all computer control. There's a lot of problems that you otherwise scratch your head or maybe use lots of ferrites in order to try and resolve with analog radios, that all of a sudden you're dealing with other problems like Windows 10 wanting to do a reboot in the middle of a contest. So this is actually, this is picture. This is not what you can do, this is what we do. So this shows the remote radio connected to a LAN with the software system that we run remotely, connected via the internet and a virtual private network server, and then using audio, TeamViewer, and a Maestro in order to control the radio. So Mark also mentioned the issues of station integration. Obviously, in the case of our remote mountaintop station, from my home QTH, it takes me about an hour to drive to the top of the mountain. It's controlled access through multiple gates, and it probably takes 25 minutes to do the last 3 miles. So it gives you some idea of, we are remote, it's a paved road. I'm very happy not to have to go up there in the winter. It's pretty wild. Even in California, yes, we do have winters. This past winter, we had 100-mile-an-hour sustained winds. So you can imagine the design that we also do on our antenna system so that we don't have to do maintenance all the time. That said, we are about to take a crane up there. So with the Flex, you also get station integration capabilities. You can plug what are essentially RS-232 cables into the USB ports on the back of the radio. These cables are capable, but the cables are available from Mouser. They're pretty inexpensive and will give you either serial to serial access or serial to individual control lines. So Flex provides a fairly sophisticated set of capabilities in Smart SDR that allows you to go through and say, okay, if I'm transmitting on this particular band, I want this particular line to be turned on when I transmit. So you can use it for amplifier control, you can use it for antenna switch control, and for certainly typical stations, you can probably do the majority of integration just using this. This is a photograph of the antenna control matrix that we have at our remote station, just to give you some idea. So we have a pair of stacked tri-banders, one at 46 feet, one at 92 feet. We have another antenna that's at 112 feet that we use for 40 meters on top of that. And then a vertical dipole for 80 meters. Actually, tomorrow we won't be up there, but the bulldozer will be cleaning the space out for us to put a full-size 80-meter foursquare there. So as you can tell, we have a number of antennas, and so we have to be able to, we also have 2 radios, 2 amplifiers up there, so we need the ability to be able to switch different antennas to different radios. So this is the switching matrix. The gray boxes are actually bandpass filters from 4 Oscar 3 Alpha. This one in the middle that's got more wires going into it is a high-power triplexer, so we can run 1500 watts from both amplifiers into a single antenna. And we also have the ability to stack different antennas on the tower as well. So we make very extensive use of computer-controlled switches. We use a Raspberry Pi and software that we've developed in order to control this remotely. So this is what you can do. I'm not suggesting everybody wants to do it, but with a little bit of ingenuity and a lot like buying furniture from IKEA, some assembly required, it's possible to put really sophisticated and complicated solutions together. So the real world experience for us, you know, with a remote radio, it really is pretty amazing what you can do. Our mountaintop environment, we initially thought was, because we literally were on, we're beaming right over San Jose and all of the Bay Area. We thought it was going to be quite noisy. Surprisingly, the site is really quiet. And so with the receiver performance that you get in a Flex 6000, it's really spectacular what you can hear. SDR gives you brick wall filters, and because you now have all of this in a computer controlled package that sits on a network, it makes for a really good remote solution. The network latency really is one of the sort of final points I want to leave you with. The network latency really is key. In our particular case, I have about 18 millisecond round trip time from my home to our mountaintop. And you know, we're very fortunate because it's all within the Bay Area, metro area, if you will. We're not having to go out across long haul internet links. It's all regional. So certainly within your regional area, you can get amazing network coverage, and you know, this gives you some idea of what you can do. So with that, thank you, and I'll pass it back to Mark.
Thank you, Stu. Yeah. Thank you, Stu. That was great and inspiring and a little scary at the same time. So we have about 15 minutes for questions for either me or Stu or other experts in the room. So first, yeah.
In your opinion, is the remote rig about the best embodiment of the audio transport?
So the question was whether the remote rig boxes are best for providing audio transport. They do a very good job. There's other solutions too, like Stu mentioned, and Flex actually digitizes the audio and sends it over the network. So when you use the Flex solutions, you don't need remote rig boxes at all, although you may want to use them. Anything else?
Yeah, as I said, I mean, if you're DXing or if you're rag chewing, the audio link remotely that is provided in Smart SDR or in Maestro works very well. If you're contesting and you're really concerned about the round trip time, the turnaround times, you may want to explore custom solutions, and that's the reason why we went with something else. But the remote audio that's in Flex Radio does work very, very well. Yes?
Give a little more detail on your solution for remote CW.
Yes, so the question is, what is the solution for remote CW? So the ideal solution for us has been to use hardware WinKeyer at the remote site and control that from the computer that is at the remote site. So one of the challenges is trying to remote, if you really want to try and remote a key or CW paddles, you really must think about generating the side tone locally. If you think about the latency and trying to actually use a keyer with a paddle, you'll go nuts. So in order to get that audio feedback, which lets us all do the manipulation of the paddles, that you really need, you know, very quick turnaround time. So the side tone has to be generated locally. Maestro does have a WinKeyer internally, and then it keys the radio across the network. That does not work with a logging program. So in our case, what we do is we use N1MM or WriteLog to drive the WinKeyer. That way, particularly with the remote audio solution that we have, we also get the side tone. We can hear what the CW is that's being generated, and there are no network delays. And if we need to send a fill, then use the CW keyboard. So Alt-K becomes your friend.
So actually keying CW either remotely or locally and then transmitting it works fine. But if you want to hear what's going on in that CW, that delay is what causes all the confusion. So the CW is working fine, but if you need to hear it, then you have to think about, well, do I mirror it with a locally generated side tone? Do I generate it locally so I can hear it and then send it? So it's really the monitoring of the CW that causes the problems. The keying of the CW works just fine, but you don't know what's going on. So, all right. Yeah, in the back there.
Okay, so the question is, how do we deal with station operation and control, for example, power control for the remote station? We make extensive uses of the digital logger products that Mark mentioned. So it's a web-controlled power switch that it has multiple, so it has 8 switchable AC outlets. That's what we use. They're programmable. You can run scripts on them. You can either telnet into it, or you can use a web browser and say, turn this on, turn this off. Our remote site, we're fortunate that we have backed up power because it's a commercial radio site. And the facility that we have all the radios in is alarmed. So we have environmental control. We have a weather station that sits on top of the tower. It dumps data into the internet, and so we can monitor the temperature inside the container. We do have AC inside of it. It's a small unit. I mean, it's more designed just to avoid the temperature going through the roof, rather than we avoid trying to operate from there. Yes. So the question is, if you're not using a flex radio, how do you get a PAN adapter remotely across the network? So at Visalia, Elecraft was actually showing an iPad an application on a Windows that was showing their PAN adapter remotely. And Tom N1MM has shown some videos of using, of actually generating a PAN adapter in N1MM from an ICOM radio. So there are solutions coming. It's really a question of vendor support, to be honest. A lot of radios don't provide the kind of data in a format that makes it convenient in order to put it across the network. But it's coming. So, you know, things in 5 years' time will be very different. I think, yes, sir. Right. So the question is, how do we deal with remote software updates of the computers on the remote site? The other part of that is, how do you manage Windows 10 so that when it decides to do updates and do a reboot, that it doesn't do it at an inconvenient time? So real quickly, with VNC, we can remotely control the computers. We also have what's called remote KVM, keyboard, video, and mouse. So it's a little $100 unit that sits on the VGA, sits on the mouse, sits on the keyboard, that we can independently access across the network. And with that, we can do hardware control of the PC. We also use Windows 10 Professional. It's another $100 over the regular retail version, but that you can configure so that it will only do reboots at your control, so it doesn't just randomly do it. Any other questions?
What are you using for your antenna switching hardware?
Okay, what are we using for our antenna switching hardware? We use the 4 Oscar 3 Alpha 6x2 antenna switches. They're computer controlled. That picture of the matrix that I showed you actually has 8 of those switches in it.
There's a lot of remote antenna switches from like Microham or Top 10 devices, but the 403A ones, he has thought about remote control. So I would encourage you to encourage him to keep putting remote capability in the antenna switches. Another question or two? Oh, over here.
Like 10 levels below where you guys are operating, just trying to set up remote operation. I live in Minnesota. My wife drags me down to Florida for a Minnesota winter, and I'm
Okay, so the question is, how do I remotely control my amplifier and know what's going on with it? So I have two solutions to you. A webcam is we make extensive uses of webcams. They are relatively inexpensive. You don't necessarily need huge resolution. You don't need zoom, waterproof capabilities, and those little cameras that are network accessible, those just plug into the network, and we have 3 or 4 of them. We have one that looks up the tower. We have one that looks at the rotor displays so that we can actually read those in case the computer doesn't agree. We have one that actually looks at the matrix. The matrix actually has little LEDs on it so we can tell which ports are active. Some amplifiers, the Alpha 9500, the new Flex amp, the new Elecraft amp, or the KPA 500 are all completely computer remotely controllable. They'll read you the VSWR, the power output, the fault codes, and you can power cycle them remotely as well. Yeah. No, I understand. Well, some, particularly if you're trying to remote an existing station, then there are going to be perhaps some limitations. If you're designing something from scratch to be remote, then obviously you think about what makes for easiest control. Maybe one more question. Yes, sir. TeamViewer is a great solution. It's free, and for non-commercial use, it's free. It has good built-in audio support that is fairly reasonable to use. It's a perfectly adequate solution. If you're happy with it, don't bother screwing around with VNC. All right. Thank you very much indeed.